So here, and we're here at the MIT AI event in Davos, and it's probably fair to say that this event wouldn't quite be the way it is without your work on the transformer. Can you talk about how much of a breakthrough that transformer model meant in 2017?
Yeah, so I think a lot of the technology that people are talking about here is probably based on the transformer model. But if you're asking how much of a breakthrough it felt like in 2017, honestly, I didn't think that it was a big deal. Some of my co-authors claim they knew it was a big deal, but I have to say that I'm surprised at the amount of impact that it's had since then.
What do you think were the main achievements with the transformer model? What did it solve that we didn't or couldn't do before? I mean, I personally remember experimenting with neural networks and could never quite get them to work reliably out of sample. But tell me how you saw it.
So I can give a brief anecdote of when I did think, okay, we did have something special here, when I saw something that we didn't have before, was after we'd done a lot of experiments, I wrote code to visualize what exactly the attention was attending to in various layers. And there was one layer that was surprisingly interpretable, where it's doing something called co-reference resolution. So working out what the word it or she or her is actually referring to. And um, it was able to solve things called Winograd schemas, which were classic AI problems that people had spent years manually trying to get working, and we somehow managed to have built something that just automatically solved those sort of things just by learning to translate.
So at that point, at least, you probably felt that this could be used for a variety of applications more reliably, not just translation. Or when was that aha moment where this is pretty generalizable?
Yeah, so I think the story behind that is slightly mixed, because yes, on the one hand, we were only doing translation, and there's actually another couple of tasks that we did in the paper, but it was mainly translation. And we also amusingly say in the paper, we hope it's useful for other applications outside of translation, and obviously yes. But the name transformer actually comes from the fact that we were trying to make something that could generally transform any data into any other data.
And ultimately, now to transformer model, large language models can make reliable prediction, not just predicting the next word, but also the 3D structure of protein, or they can write code, even code to improve itself. So it turned out to be a quite general prediction engine at the end of the day. But maybe let's move on now. Now we are 8 years after this breakthrough paper. Where are still the shortcomings of the transformer model, and what are you excited now to work on to maybe resolve that gap that still exists to human intelligence?
Yeah, I think there are still shortcomings. My worry is that because the transformer model is so powerful and has been so successful, that kind of blinds people to the fact that we need to be looking for better. So the fact that now that I've started my own AI lab and I'm able to do the research that I want to, what I'm excited about is having the freedom now to spend my time, at least some of my time, looking for what's coming next. I think we both came up with a list earlier of what's missing from current AI. Maybe you can help me remember, but it was generalization. It was these things are still extremely data hungry. Something that I think we ignore because we have hyperscaling now, so we have all the data, but it's still a fundamental problem. Um,
Continue learning.
Continual learning, yeah. I'm hearing rumors in the research world that continual learning is going to be the 2026 thing that people are going to be working on talking about.
Yeah. Maybe you can talk about that misconception that people feel that, oh, the transformer model is learning. Can you maybe help explain what the transformer model does and why continual learning will be so important to resolve?
Yeah, I mean, maybe you're getting philosophical at this point, but I definitely think that the transformer is learning. It's, in the beginning it can't do a task, and then by the end of training it can. I consider that learning. Um, but so you were asking what the
More
transformer.
continual learning from new
Well,
data.
yeah.
Sorry, I should have clarified that.
The So the easiest way to explain that, I think, is that people who are not AI experts might be surprised that at its core, something like ChatGPT doesn't learn anything at all after it's trained. And surely it should, right? It should learn like a human. If it experiences something, it should learn from it. If you tell it that it shouldn't do something again, it should learn from that. So that's the sort of thing that continual learning would allow us to do.
And clearly that would be a big breakthrough to have that feedback mechanism from interactions, back into basically the learning depository and also, reflected in the parameters. But what else is there that you're excited to work on? We also talked about structure. What is missing right now from a structural perspective?
Yeah, structure and also something like causality. So there are some people who argue that these sort of machine learning models only really learn correlation, right? So what two things are happening at the same time, but might not necessarily understand um, which direction causality goes.
Yeah.
And you would get much richer structure and much better understanding of data if these models could actually learn to do that, if they are indeed not yet doing that.
Makes sense. And, it seems like you are exploring a lot of different avenues. If you had to nail it down to one where you think this is probably the area where we're going to see the next big breakthroughs, which one would it be of all the things we discussed?
Yeah, well, I'd like to first say that I'm mostly pushing open-ended exploration. So I don't want to push any particular direction. I want people to encourage people to do research that's slightly further afield. It's doing something slightly different. But what I'm betting on is I want to take more inspiration from what the human brain is doing. And right now I'm taking it from like a low level, so looking at what the neurons do. There's an entire zoo of neuron models out there that that try to model exactly what the neuron is doing in the brain. And there's a lot of low-hanging fruit there to play with, but we seem to be stuck with literally the simplest version of just adding your inputs and then having an activation function. And this model is literally from like 75 years ago. So I would like to see some progress in finding something that looks a bit more brain-like. And I think some of these properties that we need, that we've been talking about, will sort of fall out of that.
Well, I wish you all the best for the next Eureka moment, probably inspired by biological plausibility, it sounds like.
Yeah, here's hoping. Thank you.
Thank you.